All right, over the next couple lessons that we look at, we're going to be looking at polynomials and factoring. Today we're looking at adding and subtracting polynomials and the different names for different polynomials. For example, a monomial is a term that has one part to it, one term. I'm going to flip over here for a second. We've got different kinds of polynomials, which just look like the like terms problems where we were combining like terms. The name, if it's just a whole number, there's no x, it's a constant. You guys know mx plus b, y equals mx plus b is linear. If it's to the second power, if that's the highest power, it's quadratic. Third power is called cubic, and fourth power is called fourth degree, and then it keeps going fifth degree, sixth degree. The highest power in the highest exponent in the problem, in the term, is going to be the degree of the polynomial. So this is a fourth degree, third degree, second, first, and 0. There's no x there at all. Number of terms, this is one term. So number of pieces added or subtracted, this has two terms, the 5x and the 9. This has 3 terms, this has 1, this has 3. Name, if it just has one term, is called a monomial. Mono meaning 1. 2 terms is binomial, like bicycle, 2. 3 terms is trinomial, like tricycle, 3. Monomial just has one term again, and then trinomial, this would have 3 terms. So it's just called a polynomial if it has any number of terms, really. All right, so we're going to look at combining different polynomials. So simplify 3x plus 2x. I'm telling you guys, this is just adding like terms. If you have 3x's and 2x's, you combine them, you have 5x's. Now you have to remember, when you are combining like terms, what if you had 4x squared and 5x squared? When you combine them, what do you get? Well, if you have 4 of whatever and 5 of whatever, you get 9 of whatever. You're not going to change this to some different label. We are not multiplying these powers. Okay, we're not adding the powers, not multiplying them. You're just simply adding up how many x squared you have. Okay, same down here. How many x to the fourths do you have? Negative 6 and positive 11 make 5 x to the fourths. It doesn't matter if it's a single x piece or if you have x squared, y to the fourth, as long as they're like. You can't combine them unless they're like terms. So x to the squared, y to the fourth is like, they are like terms. So we're going to combine a 2 and a negative 7, which gives us a negative 5. Our label stays the same. I think my pen is dying. Okay, our label stays the same though. X to the second, y to the fourth. Now we're going to get into a little bit longer problems here. The first one they ask us to write in standard form. I do want to go over that. So standard form is where you have your highest exponent in the first term and then it just counts down. So this is a power of 1. This doesn't even have an x. This is a power of 2. So we want this one to be first, and then this, and then finally our constant. So all that means, if I had an x to the third power, it would be on in front here. So you're just putting your terms in order, largest to smallest. All right, and then what we're looking at is just adding like terms, combining like terms. So they sometimes will put a big long expression in a parenthesis and then have plus another big long expression. Ignore the parentheses for a second. It's added. So order of addition doesn't matter. We're going to look for everything that can get put together. Here's an x squared, here's an x squared. I'm going to do it with these colored. Here's a plain old x. Here's a plain old x. Make sure I remember that negative goes with that. And then here's a number. And here's a number. Now, I don't see another x to the third power, so I'm just going to write that again. So negative 12 x to the third power. The ones I have highlighted in pink, 106 and 14 will combine together and make 120. They are both positive, so it's going to add up to 120 x squared. The green, negative 241 and negative 14 make negative 255x. And then finally the blue, 4477 and 1545 make 6022. Now the last problem, hope nobody stopped watching early, but the last problem here is a subtraction problem. This one is a little bit trickier because you have to do this extra step in there. The first problem is going to stay the same, but you are subtracting each one of these. So this is going to be subtract 4m to the second, subtract m, and when we subtract a negative, it's really like adding a 12. So in my opinion, we are distributing a -1 to each term in that parenthesis. This -1 has to go to each piece. And then we can look at our like terms. I don't see any other m to the thirds, and I don't see any other m to the fourths. I'm sorry, m to the second. Whew, fourth, no, I don't see any m to the fourth. All right, so I see one m to the third here and this one m to the second. Now I do see this m that I can put together, and I see the whole number that I can put together. So the pink -1m and -1m make -2m. And then the +9 and +12 make +21. So this would be your final answer. Notice how I'm putting the highest term and then counting down. That's called standard form. That's how we want to put the answers to our polynomials.